You are in Lagoon K, and you are here, whether you know it or not, to hear the talk entitled When IoT Attacks, Hacking a Linux-Powered Rifle by Runa Sandvik and Michael Auger. And please put your phones on vibrate, because there's no such thing as a nice ringtone.
Hi, everyone. Does this work? No? Does it work now? Awesome. Thank you for coming. My name is Runa Sandvik. This is Michael Auger. And our presentation is essentially the summary of a year's worth of research on a Linux-powered rifle. The goal with the talk is to focus a bit more about how we actually did the research as opposed to what we found. But we also have a couple of demos and a couple of interesting pieces of information that the media hasn't covered yet. So Tracking Point has been widely covered in the media over the past 2 years or so. It's a Linux-powered rifle. It has Wi-Fi. It can connect to your mobile phone, to your tablet. It has USB ports, the software updates. It's a pretty interesting piece of firearm plus technology. We often get asked why we decided to hack a rifle or a firearm. And I told CNN last week that it's because cars are boring, but then they chose not to include that in the actual clip. But really the reason was that it was just a really fascinating piece of technology, and we just wanted to take it apart, hack it, and see what we can do with it.
So the platform we were working on is the Tracking Point TP750. The base rifle is just a Remington 700 308 bolt action. The hardware platform, which is the scope that Tracking Point actually built, is called Cascade. They've got a smaller platform for the shorter range rifles, which they call Ares. A lot of the things we found here we're fairly certain would work on Ares, but we haven't gotten our hands on one to actually test that. But it's just a Linux machine, runs Angstrom Linux, very similar to what you'd find on a BeagleBone Black. 255 mega RAM, 600 megahertz processor, ARM v7. There's a 16 meg flash ROM that holds 4 Linux kernels, and then the file system's on a separate non-flash that's 4 gig. The way the system's intended to work, in their advanced mode, you've got what they call tag, track, exact. So tag, you're looking through the scope, you line up to the target that you want to hit, and you hit a red button in front of the trigger, and it tags the target. The second frame here is the crosshairs moving. So essentially once you tag the target, there's a laser rangefinder on the scope. It hits the target, calculates the distance. The gun or the rifle then calculates the ballistics required to actually hit the target there, taking into account variables like temperature, distance, all these different things. So then you pull the trigger, the crosshairs turn red. You then line back up to that target, to that tag on the target, and when you're lined up, the rifle fires. So there's an interaction between the scope and there's a link that goes to the trigger mechanism that holds the firing pin from firing once you pull the trigger. All this can also be recorded to videos, so you can pull those down later as well.
Just 3 things to keep in mind during this presentation about the research is the attacks that we have require the wireless network to be on. So by default, the Wi-Fi is off when you take the rifle out of the box, but you can choose to actually use the Wi-Fi if you want to. In addition, the rifle cannot fire remotely. So there's a lot of things that we can do, like we can prevent the trigger from working. We can actually lock the owner out of the rifle, but we cannot fire remotely. And lastly, the TP750 is a firearm even without the scope. So it just means that if the scope is bricked, if it doesn't boot, it's still a firearm. You can still fire, you can still shoot. You're just gonna have a really hard time aiming anywhere. So when putting together this presentation, we wanted to focus on how we did the research, how we actually got the rifle and where we started taking it apart and sort of trying to figure out a way in. So we divided it up into sort of round 1, round 2, and round 3. And so for round 1, we sort of start off with just what the scope looks like when you just take it out, when you have it in front of you. It has a couple of buttons for wind, focus. It has a sensor for temperature. It has a microphone because it films when you're doing the shot, and it can also record audio, and it has a couple of USB ports as well on the front of it. So the first thing that we did was that we ran a port scan, as you do when you have a rifle that has a wireless network. We found that it runs a web server and a GStreamer service. And that was it. There wasn't really a lot more to look at. We tried a couple of other things, like giving ourselves a different IP address to see if anything else would pop up, but we didn't really have any luck. So at this point, it sort of seemed pretty locked down. So in addition to the rifle, Tracking Point created mobile apps to interact with the rifle. So there's one app that's called Shot View that looks like this, which just allows you to see exactly what the shooter is seeing inside the scope. So it just streams exactly the same view. Got it. The next app, and sort of the slightly more interesting one, is called Tracking Point. That's the app that allows you to change things like wind, temperature. You can select the type of ammo that your rifle is using. You can download media off of the scope, and you can also do software updates from this mobile app. So when we started digging through the mobile apps and looking at the communications between the apps and the scope and what the scope was doing and what it was doing when it was booting, the wireless network has a key. It's a WPA2 key that's guessable, but it's there. So you need to know that key to actually connect to the wireless network in the first place. We found that the communications between the app or the apps and the scope, it's HTTP only, but well, it's WPA2 and it's pretty locked down. Otherwise, so that wasn't a big deal. We found that it uses HTTP only when it's pulling software updates from Tracking Point's website, from trackingpoint.com, and to the scope, it's using HTTP only. But then we discovered that all the software updates are GPG encrypted and signed with a passphrase. And so already at this point, we didn't have a whole lot of exciting things. But we then decompiled the mobile apps, and we got the sort of the public API, the options that are available to you when you're communicating with the scope. And yeah, again, there's a couple of interesting bits and pieces here. You can set the wind, you can set the temperature, you can set factory defaults, you can check the version, you can update the scope, but again, that's sort of what you're supposed to be able to do from within the mobile app anyways. So at this point, we sort of felt like we didn't have all that much exciting. We sort of were hoping that it would be easier. We sort of got into this project with the idea that this was going to be a really fun experience. It was going to be a challenge. We were going to learn some things. It wasn't going to be super hard. And then already at this point, in sort of round one, we found that yes, you can do stuff with the mobile app, and anyone who can connect to the Wi-Fi can do stuff. But that was about it. So we did what you usually do when you sort of get stuck. You try a lot of different things. Like I said, we tried port scans. We tried to push different button sequences on top of the scope to see if like an admin mode popped up. We didn't really find anything there.
Yeah, at one point, we quite literally tried the Konami code. Did nothing.
So sort of after this round one, the sort of findings that we were left with was that the SSID of the Wi-Fi contains the serial number of the firearm, and you cannot change this. It pops up as TP750 _
Serial number.
The serial number, and you cannot change this. The WPA2 key is easy to guess, and you cannot change it either. Any RTSP client can actually stream the scope view or just download the Shot View app that allows you to see exactly what the shooter is seeing. We found that the API is unauthenticated, so anyone who can connect to the Wi-Fi can actually change wind or temperature or do any of the other things that you can do within the app, but it does validate input. So if you pull up the app and you go to change the temperature, for example, you're going to get a drop-down that just has a very very short list of values that you're allowed to put in. If you try and actually send a value that's not in the list and outside of this range, the app is not going to accept it. We found that so Michael mentioned to do the tag track exact, you need to be in what's called advanced mode. Now, from within the mobile app, you can set a 4-digit PIN to lock advanced mode, so anyone who gets the rifle will need to actually either pull up the app or then on the scope or on the gun itself, enter this 4-digit PIN to unlock it. But it's 4-digit, it's pretty easy to brute force, or you can just use the API call of set factory defaults, which will just reset the whole thing and there's no PIN anymore.
And a note on that, when the PIN is set, you're not supposed to be able to get 2 set factory defaults. When you load the app up and there's a PIN, it pops up on the phone. It's like, enter your PIN to get anything with this app. But because the way the API is structured and there's no authentication, you can just set factory defaults and it's like, okay, cool, takes it and just resets everything and now there's no PIN.
And then the last item there was something that we saw that, oh, hey, it's pulling software updates over HTTP. This is really exciting. There has to be something here. But they're encrypted and signed with GPG with a passphrase that we don't have.
That was very disappointing.
So at this point, we decided to move on to round 2.
Yeah, so at this point, we've been treating it kind of like a black box, right? It's what can we do with it? What can we poke? Do some basic recon. Didn't really find much clearly. So now it's time to get a little more physical with it and start tearing things apart. So started doing some recon on Tracking Point's website to see like what resources can I find? What can I find out about this thing and what it looks like inside before I actually tear it open? So on Tracking Point's website, they had this lovely picture. Looks very similar to a CAD diagram. It's got screws, all these other things. Looks, somewhat right. Dig further, find a white paper, kind of the same thing on the flip side. You can see the trigger link mechanism. You can see the button underneath the scope there. That little red button is what you use to tag with. So when you tear it open, it looks exactly like that. Go figure. They actually use their CAD diagrams in their marketing stuff, so that was convenient. Dig around a little bit more. One of their YouTube videos, they had the circuit boards, some of the circuit boards anyway, during the fab process laid out. To give you an idea of why this was a pain in the ass, these circuit boards are flat right here, right? This makes it great. But in reality, inside the scope, it's a 3-dimensional layout. So it's all this rigid, flexy design. There's 9 circuit boards in this thing. So when you decide that you're going to probe something, it's no longer just I'm going to spend 5 minutes and hook up to this and probe it. I have to tear a whole bunch of stuff off to get to what I even need to probe. So here's a close-up of that. Over on the right side, you can see there's some pins underneath that focus knob. There's like 20-something pins there. There's another few pins right under the kind of ribbon-looking cable thing there. And then there's 40 pins on the right side. So literally to get to the inside, or to pull this thing out, you have to desolder 60 pins minimum. So it's, no small task. Here's a close-up. So once we're digging into this, they were kind enough to document everything well with nice silk screening. So we pull this open, find this TXRX, and we're like, hey, that sounds familiar. Maybe that's UART. So we took a bus pirate, hooked up to that, turned on the scope, and there we go. We had a boot screen. So this was extraordinarily exciting. We're watching it boot. Yes, all right. And then it got to this. Here's a close-up for people that couldn't quite see that. Straight to a login prompt. We've all seen the projects where you hook up to UART and dump straight to a root shell. That's kind of what we were hoping for. Not the case. So we, of course, tried all of the, blank password. Is the password password? Is it let me in, the top 10, all these things. None of those. Tried stuff off the website, tried things that made sense, just, bang our heads against the wall. Well, this is going nowhere. So round 2 findings. The console is password protected. The kernels we discovered when we were doing this are on that separate file system. So as part of the boot process, once we had access to everything, we noticed it was running U-boot. So hit a key, interrupt the boot process. We've got U-boot, a bunch of commands, and there's a memory dump command inside of U-boot. So we're like, cool. So other systems, you can actually use that command to dump the file system. You get the whole thing out, and it's not quite a direct thing. You have to basically use a script, and you dump small sections at a time so you don't overflow and miss bytes and all this other jazz. Took about 4.5 hours to run. Did I mention this thing's battery powered? So when it's normally running, there's 2 batteries. One battery lasts about 3 hours, then it kicks over to the second battery. That only works when the system's running. It can monitor the status. When it's in U-boot mode, there's no status monitor. So it's running, and all of a sudden it was off. And we're like, ah. Oh. Then we go look at the file, and it's like 15.5 meg. And that was pretty disappointing. But we did discover that in this 16 meg dump, once we finally got the whole thing, we run it through binwalk and strings and all this, there's no file system, just 4 Linux kernels. So clearly this wasn't going to work for us either. So round 3, we've poked at it without getting really destructive. It was time to get destructive. So this is what this looks like when you completely tear it out. We met up with Bobik. He was kind enough to help us out with this. Desoldered all the pins for us. It was a tremendous amount of work. Part of when we went up, we kind of lifted the circuitry up, and you could see some of the chips on there. And there was another chip on the bottom. We're like, oh, this is another storage chip. That must be the file system, right? And didn't really quite comprehend the data sheet, and 512 megabits is not quite 512 megabytes. So we're very excitedly like, let's pull that chip and just dump it. So if you look up at the top there, there's a kind of blank space next to the FPGA. So we pulled that chip off and dumped all 32 meg of it, and then promptly realized, wait, this chip is sitting next to an FPGA, which needs to be programmed every time it boots. All this chip is doing is programming the FPGA. So that was a very happy, sad moment all at once. But for those that are any good with hardware, can anybody find the file system chip on this diagram? You can see it. I'll give you a moment. All right. Here's where it actually is. So hiding underneath this big capacitor. So we actually missed this multiple times after we pulled this all apart. We were looking around, looking for things, well, there's no more chips. And if you get at the right angle, you can see this little chip, and you can see some of the silk screening on that. That shortcode there happens to be Micron's shortcode for their BGA package, and Micron's one of the few manufacturers that provides a conversion tool. So you throw in the shortcode, and it gives you the actual chip model number, and you can look up the data sheets, and there it is, a 4 meg or a 4 gig non-chip. So there we go. We found the file system, but we didn't have any way to access it yet. We tried quite a few things, thinking maybe it was going through USB or all this other things. There was a whole string of other failures at this point. So we ended up talking to some more friends, got connected with some really smart guys in Portland. And we're like, hey, can you help us pull this BGA chip off and dump it? Because at this point, we're just like, we just want the file system. We don't care if it works when we're done. Get us the file system. And they're like, we can do that, but it may not work. We're like, we don't care. Can you help? They're like, yeah, absolutely. So packed everything up, flew across the country to Portland. And once we got there, given that they're really good with hardware and understood some of the stuff we didn't, they looked at the silk screening and they recognized these labels. So DA0 through DA7 and command maps to eMMC. So they recognized this, they made some phone calls. Well, there were some other adventurers trying to do it other various ways, but they made some phone calls, talked to one of their friends who happened to have this device. This is straight from Alibaba, $118. It's an eMMC to USB adapter. So works great. It's got the socket. It's actually pretty cool. The socket is actually probably worth about $100 on its own. But you can, if you desolder the chip, you can drop it in that socket, plug it into USB. It's just an external, basically USB drive at that point. But there's also that row of pins between the socket and the USB adapter. So we just bridged those pins to the pins on the circuit board with it all opened up, plug it into a computer, and we had the file system. It was a very good day. So first thing we did once we got the file system, after looking at the Etsy password file, was looking at the root of the web server. And lo and behold, there's a bunch of API calls that we couldn't find. There's a few interesting things here, right? Look at that last one, SSH_accept. That sounds kind of interesting. Right, so we got to play with these and see a little bit more of how this thing actually works.
So we put together a couple of demos, and I figured I would just explain a bit about exactly why they work or how they work, and then we'll show the demo after. This first one, if you've read the Wired article or seen the video that was published along with the article, you've seen some of this. But what happened here was once we found the list of API calls, we found a very specific call that just opens another port in the firewall. So again, your only requirement at this point is that you need to be on the wireless network and you need to know about this API call. That's it. There's no other authentication in the picture. So using the API call opens a port in the firewall. you just connect to a standard socket. And while the mobile app will validate the input, so I said you get a drop-down list for temperature, for example, and it has just a set range that you can select within. The system backend that you connect to this way does not validate any input at all. So what we did with Wired was that we connected directly to the system backend, and then we changed the value for how much the bullet weighs. So instead of the default value of 175, we just changed it to 500,000, and the system happily accepted this new value. By communicating directly with the system backend, we can make temporary changes. So we have to be on the wireless network as the shooter is sort of lining up to take a shot, or at least as the shooter has the Wi-Fi network on. We can only make temporary changes. So if the owner of the rifle reboots at that point, our changes will be lost. But we can change wind and temperature as you can in the app, but we can set values that are outside of the sort of predefined range that you have within the mobile app. We can set different values that the scope will use for ballistics calculations. So we can, set the rifle to just think that the bullet weighs 500,000 instead of 175. We can lock the trigger so that you can never actually fire the rifle. What else can we do?
And also in the back end, so through the API rate limits how fast the commands get sent to this back end. Once you're directly connected, you can just throw stuff at it, and it does not like it. It will crash really quickly when you do it, which is really fun when somebody's lining up for a shot.
There's also, you can also make the scope believe that it is attached to a different firearm. You can make the scope believe that you're using a different type of ammo than what you actually have. The system backend has a lot of options that they're there, but they're not fully implemented yet. So it's sort of like in the future, maybe we will turn this on type of stuff. It also has a command that it's just fault, like a seg fault. And if you type it in, it will just reboot the whole system, and then your scope is back up and running. So it was this functionality that we then used for the wire demo that we figured we would show you now, which similar to what we did, or to what you've probably seen in Wired, but just shot from a different angle. Sure, yep. Go for it.
All right, so this is what happens during normal operation, right? So you line up for the shot, you tag the target, maybe.
Eventually.
Maybe. Yeah, so you line up for the shot, takes a minute, little unsteady, tag, sets your tag, pull the trigger. Once you line back up to that, it fires. So hits roughly exactly where you tag. And granted, we're only at 46 yards because Wired wanted to be closer for video, but the same functionality works on this scope out to about 700 yards. Works exactly the same and works really quite well. So once we connect to the back end, we adjust that value. So we adjusted the bullet weight from 175 to 500,000. You notice a little difference in there? The crosshairs jumped quite a bit. So you line up, you're trying to hit that target, it fires, and there you see, hit the target on the left, almost dead center. So here's a side-by-side of that. So first one lines up. Now you're going to line up for the target. The second one, a little bit different with how we calculate the ballistics. Both fire. The one on the left hits centered. The second shot on the right hits the wrong target. And as far as the shooter's concerned, short of noticing that, hey, that jumped oddly far for being 50 yards away, as far as they're concerned, they're lined up to hit the other target.
So I guess there's a couple of, do you want to jump back one? Just a couple of other things to mention about the HUD. You should be able to see like a Wi-Fi indicator on the right-hand side there that has a tiny number under it. So if someone else does connect to your rifle over the Wi-Fi, you will see that number change to 2 or 3 or however many devices are connected. But at least in my experience, unless you're a very experienced shooter, you're going to be more focused on your target than actually the tiny values in the HUD.
And the other thing with that as well, with the eye piece or eye protection piece that's there, it puts you at a distance away from the view screen that oftentimes will put the stuff on the periphery of this screen outside of your field of view. So unless you're really close, you don't actually get to see the things that are up in the edges. And like Ruto said, you're probably not paying attention to them anyway, unless you're an experienced shooter.
So at this point, we had managed to make the shooter miss the shot. That was sort of at the top of our list of things that we wanted to do. And we managed to communicate with the system backend, but that was just the part of the system that does ballistics. We wanted full-on root access to the Linux system that was running on the scope. So what we did was in digging around to try and figure out exactly how this software update feature works, we found that there's an update script that when you upload your GPG encrypted and signed software updates, this script will then check the signature. If the signature verifies, it will move on to actually unpack the update and run it. Sorry. But what we found is that Tracking Point operates with 2 GPG keys. So they have one that the company holds and one that is on the scope. Now, for anyone who's used GPG before, when you try to verify the signature of a JPG signed file, if you do not know about the public key that has signed this file, GPG is going to tell you that it can't verify the signature. In this case, Tracking Point does not check which of the 2 keys actually signed the update. So since there's a GPG key on the scope and the password is in clear text on the scope in the update script, I can use that private key to actually encrypt and sign my own custom software updates that any Tracking Point firearm will happily accept.
Here's a demo of what that looks like. So first part of this, we'll SSH in or attempt to SSH in as hacker. So the first part here is hitting that SSH_accept API call to open up port 22. That call literally just passes to IP tables open port 22. It's pretty fascinating how they did it. So then we try an SSH, permission denied. Right, so now we'll upload the package and execute that. And this is what you see in the HUD when that's happening. So you get your update in progress, and this is a custom update. So yeah, that happened. So then the scope reboots, comes back up. Once it's back up, turn on the Wi-Fi, then we'll reconnect to that and try SSHing again. In this boot process, you don't get to hear it in here, but when the gun is booting, it does hit the trigger. So you get this click mechanism. And it was really interesting. When we were working on this, we'd both be poking at it, all of a sudden the gun would click, and we're like, wait, did you do that? So here we go again. We've reconnected to the Wi-Fi. We now hit that SSH accept again, opens up port 22. Now we SSH as hacker. No password, we're in, and we are root.
So as I mentioned before, the system backend would allow us to just make temporary changes. A software update will allow us to make permanent changes to any Tracking Point firearm that we are within Wi-Fi range of. So the easiest sort of thing to demo was, of course, to just get root, but you can do a lot of different things. You can permanently brick the scope. You can open the firewall. You could do just, you got root. You can do whatever you want at this point. So sort of to summarize round 3, we found that the admin API was also unauthenticated. You need to be on the wireless network, and you need to know about that admin call, whether it's SSH_accept or something else. You just need to know about it to use it. The system backend is also unauthenticated, so once you got that port open, you just need to connect to it, and then it will just happily accept any value you send to it, even 500,000 or segfault. The GPG key on the scope can be used to encrypt and sign updates that any Tracking Point firearm will accept.
A note on the back end not validating input. If you were to pass, say, 340 A's to one of the variables, yeah, that makes it crash. So yeah, all of this is really cool. we were able to get root, all of this. All of this also required us to have previously accessed the system. We've had to dump this and get the GPG key out to be able to do this. So one more thing. A couple of late nights with Kenny and Jesse in Portland. I don't know how many of you have ever made a firearm routable on the internet before, but I have, and it's kind of cool. So they're working in Portland, we're sitting in DC working on it, and we were able to get full remote code execution. So here's an example of that. Pretty much tracking point autopone right here. So we wrote the nice script, we're connected to the Wi-Fi, we run that. It instructs you to go to another terminal, run netcat and tell it to listen on a specific port, go back and hit any key. It will upload a package, run the update scope, and pass a root shell back to your netcat listener. So look at the host name, we're sitting on the scope, who am I? We're root. So this one's a little more fun because now you don't have to have ever touched one of these things before. If you can get on the Wi-Fi, you're root.
So what it's using in this case, so I keep going back to the mobile, the API that you have within the mobile apps, validate input. In this very specific case, you're using the software update functionality, and instead of uploading an actual package, you're sending a command that for whatever reason the system is just executing. So it's not all that bad, despite being able to make the shooter miss the shot, getting full root access, creating custom software updates, it's not all that bad. Tracking Point actually did a lot of good work when putting together this system and trying to secure it. Better than what we've seen for other embedded devices. The two USB ports that you have on the scope are disabled during boot. The marketing material says that it's for some future accessories of some kind, but they are disabled during boot, so you can't really do anything with them. When you're tagging a target or when you're taking a shot, the scope will save a video that you can then download onto your phone and put on Facebook. According to Tracking Point, that was a part of the point.
Or using a Black Hat presentation, whichever.
Or that. But as soon as you download the videos from the scope, they are deleted. So if you, for whatever reason, have to send your scope back to Tracking Point, the videos will no longer be there. WPA is in use even if the key cannot be changed, even though the key is guessable, at least by people in this room. It may not necessarily be that easy for other people. The API does validate user input, sort of. So when you're using the mobile app, you cannot set any sort of crazy value from there. And I don't think a lot of other people will be pulling up burp to try and feed other stuff to their rifle. Console access is password protected. Software updates are GPG encrypted and signed, even though Tracking Point's implementation wasn't exactly what it should have been. They actually did take a lot of steps to secure the platform.
So will this get better for Tracking Point? So we reached out to them starting in April. We sent 3 emails. Up until Andy wrote the Wired article, we had yet to hear back from them. He was able to get a hold of them, talk to one of the founders. As soon as he got off the phone call with Andy, the founder reached out to us. He talked to us. He said we're doing great work, glad we're working on it, was happy to work with us. They are working on a patch to patch these things. It's not available yet, but at some point, hopefully, they'll get that out. But as a vendor, they've been phenomenal to work with, and I wish more vendors would take the approach that they have.
So yesterday, for those of you that didn't see the tweet, Tracking Point put up this notice on its website. That I don't know if you can see it from the back of the room. But it does say that we're working with the consultants. That would be us. It says we will provide you with a software update if necessary. I think it's safe to say that it is. The gun can only be compromised if the hacker is actually physically with you. And the best part...
Or on your phone or something else.
The best part is you can continue to use Wi-Fi if you're confident no hackers are within 100 feet. So this is currently on Tracking Point's website. I thought it was pretty funny. But yeah, so far they have been very, very great to work with. They are definitely positive to the research that we have done. They're very interested in actually fixing the issues as well.
So on a wider note, just as a whole looking at this project, this has been said numerous times by numerous people over the years, but the vendors still need to level up. The issues found here are not unique to this product. Other embedded systems have these same problems, and too many vendors ignore the low-hanging fruit. So in this case, Tracking Point's building rifles that run Linux. They knew they were going to get a lot of attention for it. They took some precautions around that. So they did put the password on the shell. They did do these other things, and it's things that other vendors completely ignore. We dug around trying to find some resources to recommend for embedded systems specifically. Just low-hanging fruit, an OWASP Type 10 for embedded systems hardware specifically. One doesn't exist. The two best things we could find were Build It Securely, which has a lot of good resources for just general security things you should do when you're building a system. Then there's the OWASP IoT Top 10, and a lot of the things in there would have actually fixed some of the issues we found with the API authentication and things like that. But yeah, up to today, we're short of individual researchers, people like Joe Grand going out and giving presentations saying, here's stuff that people should be doing to secure their products. There is no kind of resource for people to reference.
I guess just to drive that home, the issues that we found clearly aren't unique to this project. It's not like these are issues that you will only ever find on a firearm. These are very low-hanging fruit, easy to fix, and issues that you probably do see in other embedded devices as well.
So this project definitely would have been possible without the help from the community and people involved in it. So great thanks to everyone on this. Definitely some of the things here would not have happened without some assistance.
It's been incredibly fascinating to see just people within this community that I have never met before just drop everything and spend a week with us in Portland to actually hack on it and get the demos working and get the file system. Actually, at one point when we were going up to Portland, because we really wanted to pull that chip with a file system, I was emailing with the guy that was going to help us with it. And as it turns out, when we showed up in Portland, I never told him that it was a firearm. I just emailed him and specifically told him, like, we have this chip, it has this number, we really want to get the contents of this chip. And he's like, cool, that's great.
Yeah.
He didn't ask any questions, I didn't see anything. And so we show up in Portland and he's like, oh, is that a firearm? Yeah. But yeah, it's been great working with all these people.
So thank you everybody for coming out and listening. I was happy to take questions now if you have any.